Hey guys, today we'll be solving Maths paper 9709, May June 2017, variant 1-3, and this is question number 9 of this paper. So question number 9, part 1 says, express 9x squared minus 6x plus 6 in the form ax plus b whole square plus c, where a, b, and c are constants. So what I'm going to do is take 9 common from 9x squared minus 6. So this will become x squared minus 2 upon 3x plus 6. I'll be doing the completing the square method here, right? So this will become 9x squared minus 2 upon 3x. Now you'll divide your b by 2, that is 2 upon 3. So you'll divide it by 2 and square it. First you'll add the square and then you'll subtract the square. So plus 1 upon 3 square minus 1 upon 3 square plus 6. Now this part will become x minus 1 upon 3 whole square, and this minus 1 upon 3 square will multiply with 9 and become minus 1 plus 6. Now as you can see in the question here, there's something beside x, that's a, right? So I need to express it in this form, so I have to take this 9 inside, and how I'll take it inside is I'll do it 3 square so that 3 can come inside the squared bracket, and so become plus 5. And when I send 3 inside, it will become 3x minus 1 whole square plus 5. And that is the answer to your first part. And the second part, let's go forward to the second part. The function f is defined by fx equals to 9x squared minus 6x plus 6 for x is greater than equals to p, where p is a constant. State the smallest value of p for which f is a one-to-one function. Now for a one-to-one function, you have to make sure that your quadratic curve is limited to a vertex or to your turning point, right? So for example, if this is a quadratic curve, this is your turning point, you're going to have to limit it to the turning point. So that means you can either take the part of the curve before the point or the part of the curve after the point. And since it said x is greater than p, so x is going to be this turning point, that is p, and it says greater, so I'll discard this part, so I need this part. And p, as you know from the first part, is going, since our turning point was x is greater than 1 equals to 1.3, so p is going to take the same value. Okay, so third part. Our third part says that for this value of p, obtain an expression of f inverse x and state the domain of f inverse. So first I'm gonna assume that my fx is equals to y, and from the first part I know the equation of fx, and this is this 3x minus 1 whole square plus 5. I'm gonna take this equation and write it down. 3x, just a second. Okay, 3x minus 1 whole square plus 5. Now fx, I'm going to change this to y and work towards making x my subject in this equation. So when I'll be making x my subject, it will turn out something like this. Plus minus plus 5 will go there, become minus, this square will turn into an under root over here, and this minus 1 will go here, become plus 1, and this 3 with the x will divide over here, this will become x. Now I'm gonna take x and replace it with f inverse x and replace y with x. So this will become f inverse x is equals to 1 under root x minus 5 upon 3. Now as you may notice here, I've left the space blank. That's because you have to determine whether this is going to be a plus or a minus. So how are you going to find that? You'll first have to find the domain of f inverse x, which is also the second part of this question. So from first part, we know that here, let me write it down. This is fx, f inverse x, domain and range. So as we know from the first part that our domain is greater than equals to 1 upon 3 for fx, range. So range from our first part you can see is plus 5. This is your y coordinate of the vertex, and it's going to be, so your range is going to be like fx is greater than equals to 5. So the domain of f inverse x is going to be the range of fx, that is going to be greater than equals to 5, and your range for f inverse x is going to be the domain of fx, which is 1 upon 3. Now we know that the domain is x is greater than equals to 5. So if I take any value of x greater than 5, let's say 9. If I take 9, and this will become under root 4. So if under root 4 is then 2. If I take minus over here, it will become 1 minus 2 upon 3, which will become minus 1 upon 3, and the range does not permit that. The range says it's greater than equals to 1 upon 3. So I'll have to put a plus sign over here, since this is our range, right? F inverse x is going to be our range, and if I put a minus sign here, it will become minus 1 upon 3, which is wrong according to the range given. That's why it's going to be a plus sign. And moving on to part 4. Part 4 says, state the set of values of q for which the equation fx equals to q has no solution. Fx is basically y. So for what set of values of y, those set of values of y will be equal to q that have no solution. So if I just draw my quadratic curve here, and the turning point is coordinates are 1 upon 3 and 5, right? So for what values of y does this have no solution? That's obviously going to be the area under this curve, since there's no it's not intersecting any point of the curve, so it's going to be below 5. That's why a q is going to take the values of less than 5. There's no solution beneath this point, so that's going to be your answer.